Dear students, we are in continuity and differentiability. Okay, class 12, chapter number 5. This comes under calculus. We have already started in the last class and we have understood what is continuity, how to find the continuity of a function, whether a function is continuous or discontinuous. And continuity also, every function may not be continuous at all points. Some points it may get discontinuous. Point of discontinuity also we have understood by example and okay. Now let us proceed further. We will see algebra of continuous functions. Algebra of continuous functions means, see, we have seen only one single function in last class. Single function, how to see whether it is continuous or not. Like if we take two continuous functions, see, algebra of continuous functions means we will take two continuous functions. Why? Because one discontinuous function, one continuous functions, if you add or subtract or multiply or division, automatically that is going to become discontinuous function only. Why? Because one function already discontinuous. There is no use. What we have to do, we have to take two functions. Those two functions should be continuous and we will do the algebra. We will add, we will subtract, we will multiply, we will divide. Okay. Sum, difference, multiplication, division or quotient. And let us see what will happen and all. Theoretically we will see, and one example we will see. One example means one proof we will take. We need not take proof of all these things. Why? Because see, directly we can apply. Proof of these are not that much important. That's what I want to say. Okay, let us first understand the basic concept. You see, algebra of continuous functions and preconditions. What are the preconditions? Minimum two functions we will take, but these two functions are already continuous. That we have to understand. Okay, see what I am writing. Let f and g are two real valued functions. Real valued functions and continuous at x is equal to c. These are very important. This line is very important. First you understand this line. F and g are two real valued functions and both are continuous at x is equal to c. What is c? C is any real number, where c is any real number. Okay, c is any real number. F and g are two real valued functions and continuous at x is equal to c. What is c? That c is any real number. Okay, that means real valued functions and at real number, any real number, these functions are continuous. That means f is also continuous at x c, g is also continuous at x is equal to c. Okay, x is equal to c means this c may be minus 1, 0, plus 1, whatever it may be. See, for continuity's sake, I am telling that this is a real valued function and it may also be 0. Okay, that you keep in our mind. Okay, see, now we will see algebra. See, these are preconditions, two conditions. What conditions? F and g are both real valued functions and both are continuous at x is equal to c. Okay, individually f and g separately continuous means last class we have seen how these are becoming continuous and when these are becoming continuous, when these are going to become discontinuous and all like such functions. We have seen examples in the last class. Okay, now let us see the algebra of these functions. You see, number one, f plus g is continuous at x is equal to c. First you understand this, then we will go further. F plus g, that means adding, you are adding these functions. See, separately f is continuous at x is equal to c, g is continuous at x is equal to c. But here if you add f plus g also, f and g, f plus g, one function it is going to become, not two functions. See, f is one function, g is one function, separately two functions. But if you add f plus g, this is going to become one function. This function also added after adding the resultant function is also continuous at x is equal to c. This is very important at x is equal to c. Why? Because see, even normally also if you think f is continuous at x is equal to c, that c may be minus 2 for the time being. This f may not be continuous at minus 3. Why? Because f is continuous at minus 2. That doesn't mean that f is continuous at minus 3 also. It may or may not be. Okay, that is very important. But definitely f plus g is continuous at x is equal to c. Let us c is minus 2. F is continuous at minus 2. G is continuous at minus 2. F plus g together is also continuous at minus 2. F plus g may or may not be continuous at minus 3 or 0 or whatever it may be. But minus 2, this should be continuous, this will be continuous. Like that, you have to understand. Okay. Let us proceed further. This is addition and subtraction also we will see. F minus g. F minus g is continuous at x is equal to c. You see, f plus g also continuous, f minus g also continuous. Subtraction or difference, addition or sum. Okay. See, normally how this continuity has come? By limits only. All limits rules are applicable. See, algebra of limits also we have seen. Algebra also limits also we have seen. Okay. Algebra of limits same are applying, you see. Algebra of limits same are applying. See, algebra of derivatives is different. You must understood carefully. Algebra of derivative, addition and subtraction, okay, but in derivative, multiplication and division are different. You see, v du by dx, du by dx, like another extra step you have to take while multiplication. Division also, divided by v square minus will come and all. But for limits, no, that condition is not there. For limits, plus means okay, minus also okay, multiplication also okay, division also okay, all are limit existing, like we have seen. Same like here also. Okay. Let us proceed further. Now this is minus or difference. Now we will see f into g is continuous at x is equal to c. Multiplication. After multiplication, it is going to become only one function. This function, say this is a third function. F is one function, first function, g is second function. Both are continuous at x is equal to c. F into g is a third function. This third function is also continuous at x is equal to c. Okay. This you have to understand. Okay. Preconditions are these one. Let us proceed. Fourth one. F divided by g is continuous at x is equal to c, provided g of x is not equal to 0. Why? Because see, g of x is in denominator here. Denominator should not become 0. If it is becoming 0, then this f divided by g is not continuous or not defined, that's all. Why? Because see, limits we have seen. Sometimes limiter is giving answer 0 also. Okay. But here denominator g, if it gives 0, then that we should not take here. F by g. Why? Because something by 0 is undefined. Last class also we have discussed undefined. Okay. That is why if denominator is 0, while making division f by g, then if g is 0, then that should not be taken here. It is going to become undefined. Why? Because see, whatever all the continuity we are checking for defined functions only. function is defined or not. Defined means you proceed further. If not defined means don't proceed further. Not defined like that, you write and close, that's all. Okay. If g of x is 0, then you don't proceed further. You write not defined. This function is not defined, that's all. If function is defined, then only we will see whether it is continuous or discontinuous. If discontinuous, point of discontinuity you have to write. Continuous means you need not write continuous. See, if ask the continuity at x is equal to certain point, then you can write this is continuous at x is equal to certain point. Okay, have you understood this? Okay, see, these are not complex, simplex only. Separately they are continuous, and even if you add, subtract, multiply, divide, also continuous only. We do one thing, we take one proof. F plus g, f minus g is very easy. Even f into g also easy, but we will take f into g. F into g continuity, we will take proof. Okay, and we will proceed further. Okay, okay, see, proof of continuity of fg. That means fg multiplication, we are seeing proof for continuity. Preconditions I am writing. Again we have to write preconditions. Preconditions are let f is a real valued function continuous at x is equal to c. Okay, same like g also you write. While the f into g you are doing, what are f and g you have to know. Again, g is a real valued function and continuous at x is equal to c. See, these both functions are real valued functions and both functions are continuous at x is equal to c. Only one value we have seen. See, remaining values they may be continuous, but we will take one reference. Reference is here c. C may be -1 or 0 or 2 or +3 or 100 or √2 or √3, whatever it may be. Real value, c is a real number, we know. Okay. Now you see continuity, we have to see proof. Continuity of fg, you see what I am writing. Continuity of fg implies. Okay. You see continuity, why, how we are checking normally? Limit only. Where that limit? Limit at c. Okay. Same thing we have to write. Okay. Let me write. You see what I am writing. Limit x tends to c. Okay. X tends to c. F g x. Okay, this is function and we are applying limit for seeing continuity. Okay, you see now what I am writing. F g x is equal to limit x tends to c f of x into limit x tends to c g of x. Is it correct? Multiplication we are splitting limits. Limits we can split like this. Okay. Now you apply limit. If you apply limit, automatically it is going to become f of c into g of c. Is it correct? Definitely correct. Again you can write this fg into c. Is it correct? Correct. Then you can write fg is continuous at x is equal to c. That's all. Over. This is the proof. See, if they ask you to prove, right, to prove, this is the proof, but they don't ask, and this is not that much what we can say easily understandable or enjoyable, this also. But any function if you take and multiply, two continuous functions are there. In the last class we have discussed two functions. Any two functions, continuous functions, you take, multiply and see, multiplied function, third function also will come. You see practically whether that comes or not. Definitely it will come. Continuity. Okay. This is a simplest way of seeing. Okay. Let us proceed further. Okay, now you see, let us see another function, scalar function. With a scalar function, one other function, real function, we will see whether continuity will occur or not. Like, okay, see what I am writing. Continuity of scalar function or in bracket constant function with real function or real valued function. See, individually if you take a scalar function, this is continuous, we know very well. What is scalar function? You see, I am drawing the graph. Why? Because sometimes rather than seeing, drawing graph is very easy understandable. Okay, see, this is graph. Say I have taken f is equal to 5. Fx is equal to 5. F is equal to 5 means fx is equal to 5. Okay. See, at 0 also this is 5, at 1 also this is 5, at 100 also this is 5, at minus 5 also this is 5. Constant function or scalar function, is the value going to change with input? No. That is why it is called scalar function or constant function. Constant function value is fixed. Whatever may be, you give input. Input may be x, input may be y, input may be anything. But scalar function output is, if it is a 5, means 5, that's all. At whatever may be the value. Minus infinity to plus infinity, this value is not going to change. But we are talking about only real functions, real valued functions, that's all. Real valued functions means it will come from minus infinity to plus infinity. Whatever may be the input, if you give, the output of the real function, constant function or scalar function is not going to change. Okay. Now you tell by seeing this graph whether this function is continuous or not. Individually I am talking, not with another function. See, we are going to study with this function. See, algebra means another function you have to take and study. But individually, if you see this function is continuous or not, continuous only. Why? Because see, whatever may be the input, but it is not going to affect it. Continuously it is going to give the same value. That is why this function is continuous. Okay. Now we come back. Now let us see continuity of the scalar function with another function. Same multiplication. Okay. Let k is a scalar or constant function. Okay. And we should not write E is continuous at x is equal to c. Why? Because it is continuous at anywhere. Scalar is continuous at any value. We should not write for this. Let k is a scalar function and k is normally a real number. K is a real number. See, non-zero real number. K is non-zero real number. Why? Because if it is 0, then problems will occur. If you multiply this function with another function, then that function also going to become 0. Then there is no value. To define this, see, 0 also define only, it is not undefined, but even then you don't get any value. That is why you presume that k is a non-zero real number. K is a non-zero real number. Now, why we have taken k, lambda they have given, but from starting onwards we are taking for scalar or constant k like, rather than lambda. That is why I have taken k. Okay, k you can take. There is no problem. Why? Because f, g, h you should not take. Why? Because those will come under functions. But k you can take. K as a scalar or scalar function or constant function you can take. There is no bar. Okay. Okay. So k is a non-zero real number. Okay. Let us see now. See what I am writing. That means f of x is equal to k. Shall I write like this? When k is a constant function, first function we will take f only. Na? F of x is equal to k only we will take. Okay. Let us see g of x is also one function is there and is real valued function continuous at x is equal to c. See, continuity of this function, this is already continuous, we have already seen. This we don't think about the continuity of this fx, k. But because k is always continuous. Gx I am talking. Gx is a real valued function and Gx is also continuous at x is equal to c. See, for Gx continuity conditions may apply. For fx, k, There is no condition, always continuous, that's all. Okay, gx is a function, real valued function, and gx is continuous at c. Now we will see algebra of these two. Because algebra means algebra. See, k plus g, k minus g and all you need not see. That is always continuous. Okay, separate you can make and continuous. We will see k into g. Okay, kg. Okay. kg is continuous at x is equal to c. You understand now? kg is continuous at x is equal to c. K is a non-zero real number that you keep in our mind. K is a constant function or scalar function, and k is a non-zero real number. If k is 0, automatically this is going to become 0. There is no use. Okay. Now kg is a third function, and kg is also continuous but provided at x is equal to c. Why? Because individually k doesn't depend on c. But when you multiply with g, then this function is depend on c again. Why? Because g is depend on c. G is continuous at c only. Therefore, kg is also continuous at c only. Okay, that you have to understand. Okay. Now another one, k by g. Let us write k by g also. Okay. K by g is also continuous at x is equal to c, provided gx is not equal to 0. See, here also k is not 0, that we have mentioned already. K is 0 means there is no use. G is 0 also, there is no use. That means g is not 0. But if g is 0, then kg is 0. Okay, you can write, but that is defined. See, no use means it will come 0. That is why no use, like we are telling. But no use are not defined, both are different. Not defined, if it comes 0, g is 0 means. Why? Because k by 0 is undefined. That is why function is not going to define, then we cannot study further. That is why k by g is a continuous function at x is equal to c, provided gx is not equal to 0. Okay, this you have to understand carefully. Okay, that means if k is minus 1, then the function is going to become minus n. Minus f is also continuous like. Understand? Minus 1 by g. 1 by g. Okay. If k is 1, 1 by x. 1 by x function continuity already we have seen. Okay. Except why? Because 1 by x comes means always we have to write gx. The denominator is not equal to 0. Then the function is continuous. Okay. These are the basic concepts you have to understand. Okay. Let us proceed further. Continuity of sine function. Let us see. Let us see first sine function. Continuity of sine function. Okay. Continuity of sine x. Now you tell me sine x is continuous or not? See, proof we can do, but that proof is not that much what we can say very easy, and that is not what we can say understandable much. But if you see the graph, that is very understandable, the graph. You see how I am writing the graph. Okay, now you see, this is the graph of sine x. We are talking about continuity of sine x means the graph will come, and circle diagram also I will draw, that is also belongs to sin x only. Okay. Now we see here, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. Here also you see this is minus pi by 2 and this is minus pi, minus 3 pi by 2, minus 2 pi. Like this goes on, will increase. That's a negative side, positive side. Okay. Now you tell me, by seeing this graph, what is the domain of this one? Domain is equal to R. Any real number you can give. That means there is no restriction for giving domain. Any real number if you are giving and value is continuously, it is giving. Positive side, negative side, both. Okay. Then first of all, without seeing that proof, you tell me now whether is it a continuous function or not. Definitely continuous function. See, like constant function, how it is giving value, continuous graph. Like this only, continuously it is giving. There is no disruption. If any disruption is there, then we have to see domain, whether they are putting any condition, x is not equal to 0. Like if that is there, then even the disruption is also there, then that function is going to be called as continuous. We have seen this continuity, individual function. Okay. Now you see sin x. Now first you tell me why now it has come sin x in continuity of algebra. Why? Because sin x itself is two functions. Why? Because x is separately one function, sin of x is another function. Okay. That is why we can say that this we can take in algebra functions like. Understand? Or else directly you can say it, algebra of trigonometric functions. Trigonometric functions. Okay. What if sine of discontinuous function? No, we don't take the discontinuous function. X is a continuous function. That is why sin x we are doing. If any discontinuous function is there, sine of the discontinuous function is normally discontinuous only. That doesn't give any value. Okay. Now, first of all, you understand this graph. With this graph, can we say that sine function is a continuous function? Definitely continuous function. Whatever the value you give, negative side, positive side or 0, continuously it is going to give the result, and the graph continuously we can draw. That means values are continuously are coming. There is no diffraction, discontinuity. Plus 0 plus pi by 2 minus 0. Pi by 2 minus pi by 2 plus. 3 values are going to give same value. Why? Because there is no discontinuity. That is why we can say that this function is continuous, we can say. Okay. Now let us see the cos x also, cos x function continuity. Okay. Let me draw continuity of cos x function. I am writing, you see, continuity of cos x. Okay. Continuity of cos x. Cos x also we will see continuity. See how I am writing, plotting the graph. See, cos x graph at 0 degree already it will start full 1. Cos 0 is 1, but sin 0 is 0, but sin 90 is 1. Okay. 0, pi by 2, pi, 3 pi by 2, 2 pi. Okay. 0, pi by 2, pi, 3 pi by 2, 2 pi. Here also you see 0, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Is it okay? Definitely okay, you see. Now you tell me Here also domain, what are all the things you can give? Domain you can give R, that's all. Please see, domain you can give R. R means minus infinity to plus infinity here and here for sine or cos. See, this is cos x, this is sine x. First of all, by seeing graph, you tell me whether it is continuous or not. Continuous only. That means sin x is a continuous function, cos x is a continuous function. That you have to understand. Okay? Sin x is a continuous function, cos x is a continuous function. Both domain, anything you can give. Anything you can give. Continuously, this is going to give the result. This is difference between sin x and cos x. By seeing this graph itself, you can say that sin x and cos x are continuous functions. Okay. Now let us go for tan x. Tan x we don't draw graph, but we will draw circle diagrams of sin x, cos x, and with these circle diagrams only we will define the function of tan x. Please note that while sin x, tan x input domain, we are not giving 2n plus 1 pi by 2 values. R minus 2n plus 1 pi by 2. That you keep in our mind. Those are very important. Those are very essential. Okay. Let us go for continuity of tan x. Okay. Now we can say that sin x is continuous, cos x is continuous. At x is any value. X is R. Okay. But let us see what about tan x. Okay. See, let me draw continuity of tan x. But before that continuity of tan x, I want to write circle diagrams of these three. Sin x, cos x and tan x. Okay, see circle diagrams of sin x, cos x and tan x. And we will write, see, sin x means, see, all silver tea cups. All sin, tan, cos. For sin, these two are negative, these two are positive. This is positive for all. All silver tea cups. Silver, yes, tea, tan, C, cos, cups. Okay, all silver tea cups. All students take coffee. All positive first. Now come for cos. All silver tea cups. C, cos here positive. Come for tan. All silver tea. All students take coffee. All silver tea, tan is here positive. And what about remaining area? Remaining areas are negatives. Okay, this is very important. Okay, now you write angles. First we write values only. Angles we know 0 degree, pi by 2, pi, 3 pi by 2, again 2 pi are 0. Like that will come. Okay, values I am writing first. Values. See, sine 0 is 0, sine pi by 2 is 1, sine pi is again 0, sine 3 pi by 2 is minus 1, or else we can say 2 minus minus 1, 2 plus plus 1. 2 minus minus 1, 2 plus plus 1, remaining 0. Like this also we can understand this, what we can say, circle diagram easily. Okay. Now, sine 270 is minus 1, sine 360, 2 pi is again 0. Cos 0 is 1. See, these are values. Don't confuse angles. Angles I will write afterwards. Angles with red color pen I will write. Angles also I have to write. Okay. Angles I will write for tan. Okay. Now you see, at 0, sine by cos is tan. At 0, 0 by 1 is 0. At pi, 0 by minus 1 is 0. These two values you can write for tan easily. But what about these? Sine by cos, 1 by 0, undefined. But undefined means infinity also you can write. What? How? See here, minus infinity plus infinity at this point. Here, plus infinity, minus infinity. Understand now? That means 0 to infinity continuous. Again minus infinity to 0 continuous, 0 to again minus infinity continuous. That means minus infinity to plus infinity continuous. Disruption will come minus infinity to minus infinity. Again, sorry, this is plus infinity, minus infinity. Okay? Minus infinity to plus infinity, continuously function is there. Here also minus infinity to plus infinity, continuous function is there. In between 0 will come, real number line like. But in between discontinuity is there. But in between, is this function defined? Not defined. Then automatically we can say that tan x is continuous. Like that you have to understand. First of all, let me see what is the angles we are writing here. Here we will write 2n pi. Here we will write 2n plus 1 pi. Here we will write 4n plus 1 pi by 2. Here we will write 4n plus 3 pi by 2. Okay? General representation of angles. Are these correct or not? You see 2n pi means 0 if you give 0 pi. 0. 1 if you give 2 pi. 2 pi. 360 degree. Correct. Same you come here. 0 if you give 1 pi. 180 degree. 1 if you give 2 plus 1. 3 pi. That means 2 pi has completed 3 pi. Correct. Here also if you see 0 if you give 1 pi by 2, 90 degrees. 1 if you give 5 pi by 2, see 4 pi by 2 over. 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. Again 5 pi by 2 in second circle. Here also you see 0 if you give 3 pi by 2, 270 degree first. 1 if you give 7 pi by 2, that means see 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2 in second round, second circle. Okay, that means these general representation of angles are correct. Okay, now you tell me for tan x what is your domain? I am talking about tan x. Okay, I am talking about tan x. Domain is equal to r minus 2n plus 1 pi by 2. Is it correct? Definitely correct. We have defined tan function domain as like this, r minus 2n plus 1 pi by 2. But here domain is r, here domain is r, but here domain is not r. Domain itself is clearly defined, domain r minus 2n plus 1 pi by 2. What is this 2n plus 1 pi by 2? 4n plus 1 pi by 2 and 4n plus 3 pi by 2. These both areas together are going to give 2n plus 1 pi by 2. See, if you want to write 90 degree, or again, this is 90, 270. Again, 360. After 360 plus 90, 450. 90, 450, like that if you want, this is the position. 270. 270 plus 270. 540. 270, 540, like if you want angle, this is the position. But you want both positions. Why? Because in both areas, the tan x is going to become undefined. That is why this you have to avoid. You have to put minus. You don't give r minus this angle. You have to write. Then how can you write? You will write like this: 2n plus 1 pi by 2. This will applicable for both. You see, first you keep 0. 0 means what will happen? 1 pi by 2. That means here. Then you keep 1. After 0, 1. 1 if you give. 2 plus 1, 3. 3 means 3 pi by 2. 3 pi by 2 means 270 degree. You see, 0 if you give, pi by 2. 1 if you give, 3 pi by 2. 2 if you give, 5 pi by 2. 5 pi by 2 is again this one. Why? Because 4 pi by 2 means this one. See, each one 1 pi by 2. 5 pi by 2. See, pi by 2, 5 pi by 2. Again 9 pi by 2. Like that will come. Okay? 2 also over. Then 3. 2 into 3, 6 plus 1, 7. 7 pi by 2. You see, 8 pi by 2 means this one again. 7 pi by 2 means here will come. That means continuously if you go 0, 1, 2, 3, 4 or something like, then only these two angles are going to come. That is why we are avoiding this. Now you tell me, we are avoiding this and giving domain is like this. Why? Because domain gives the limit, continuity of the function. Why? Because x is a limit. How we are seeing continuity? Continuity we are seeing with limit only. Limit extends to c. But this c depends on input, domain. Domain. The domain is very important. Here domain is R. Here domain is R. Real number. Any real number. Minus infinity to plus infinity you can give. But here clearly defined. Domain you should give R minus 2n plus 1 pi by 2. Now based on this theory, now you tell me tan x function is continuous or not? Continuous only. Why? Because see, in defined, see how continuity we are defining. In defined area, the function should be continuous. Undefined area, if it is not continuous also, we don't bother. Why? Because see, we have already seen one function, 1 by x. If f of x is equal to 1 by x, but x is not equal to 0, then this is continuous. That means in x area we are not giving 0. If you give minus, x is less than 0 also continuous, x is greater than 0 also continuous, but x is 0, it is a discontinuous, but we are not giving x is equal to 0. But this function is continuous like we have already studied in last class. Like this only same. Minus infinity to plus infinity continuous. Minus infinity to plus infinity continuous. But in between these two areas, the function is not defined. That means wherever defined area is there, in the defined area, tan x is continuous. That means tan x function is continuous. Like that you have to analyze. Okay? Now last concept, one concept is there. Function of function. FOG. Okay? That we will study. We don't take proof. See, rather than taking proof, clearly you have understood this concept. Okay? F of g also we will study and we will close this class. Next class we will start a 5.1 exercise directly. Okay? Let us go for function of function. Okay. See, continuity of functions. Okay. What is function of functions? FOG, GOF, FOGOH. Like this. These are called function of functions. Okay. These are called function of functions. Why? Because this is not f into g, f plus g, f divided by g, f minus g. Not like this. Function of function. One function already is there, g. Again function of function, f of g you are seeing. G is a function, f of g you are seeing. F is a function, g of f you are seeing. H is a function, g of h you are seeing. And again f of g of h also you are seeing. These are called function of functions. Okay. See, algebra normally we will take 2 only, 3 and all afterwards we will see. Normally you can understand if 2 if you take, then we will see only up to 2 first. Let us understand. Function of function means 2 functions. Same conditions again I have to write, I will write. Okay, see, let f is a real valued function and continuous at x is equal to c. C is a real number. Okay. Again, I need not write this. Okay. Same like G also. G is a real valued function continuous at x is equal to c. These two functions are there in front of you. These two functions. Okay. F is there. F is continuous at x is equal to c. G is there. G is continuous at x is equal to c. Now we can say f of g is continuous at x is equal to c. You understand now? That means continuity of a function of functions also continuous only. Provided f of g is continuous, g is continuous, f is continuous, g is continuous at x is equal to c, then f of g also continuous at x is equal to c. Okay, for this there is no required, proof is not required. Anyway, next class we are starting exercise. In exercise all these questions are going to come. All we do, see how many questions you do, that much of concepts are going to be cleared for you very well. Okay. We need not see the proof of this function of function. Even if you want, you can take also 2x plus 1, one function is there. Another function x square is there. 2x plus 1, first you see continuity, then you put this in x square. That means 2x plus 3 whole square. Again you make and you see the continuity. Both are going to give continuous only. F of g also going to give continuous. See, practically we will see. That's what I wanted to say. Okay, practically that means exercise, these questions are going to come. There we can understand easily. Okay, let us stop this class here and we will meet in the next class and we will start exercise 5.1. Okay, thank you very much.